Today in Capechi's Corner, we're looking at parallel line theorems. Our first theorem says if two lines are parallel, then all points on one line are equidistant from the other line. Now, in looking at our diagram, we have two parallel lines, and whenever we're measuring distance, we want to go at a 90-degree angle. That's our altitude, so that way we make sure we're going the shortest distance from one line to the other. So if we know that this segment right here is 4, then we know this segment and this segment are also 4 according to this theorem. So we know that x is equal to 4, and we also know that y is equal to 4. Our next theorem says if three parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So we can see right here we have our three parallel lines by the markings, and I can see that this is a congruent segment here, has a value of 8, and this is it's congruent to the other segment, which is also value 8. Now, that means that on this other transversal, we also will have congruent segments. So if this segment here is 9, then we know that y is also equal to 9. One thing to notice on this, it means that each transversal cuts off congruent segments, but these segments are not necessarily congruent to each other. So notice this side has a value of 8, and that side has a value of 9, which is okay. You just have to be careful. Our next theorem states a line that contains the midpoint of one side of a triangle and is parallel to another side passes through the midpoint of the third side. So this theorem's a little wordy, so we just have to be careful. What it's saying down here is that if I'm given that B is the midpoint of CA, so if B right here is the midpoint of CA, and we also know that BD is parallel to CE, then my conclusion is that AD is equal to DE because D is the midpoint of that third side. Our last theorem today says the segment that joins the midpoints of two sides of a triangle has two things going on. Number one, it's parallel to the third side, and number two, it's half as long as the third side. So again, if you look at my marking, I can see that I have a midpoint here and a midpoint here. That's the information that's given. So the conclusion I have is that this side is now parallel to that third side. And we also know that it's half as long as the third side. So for instance, if I know this measurement here has a length of 10, then I know that the smaller segment right here that's parallel has a measurement of 5 because it's half of 10. Now let's look at the example. We have four parallel lines here, and I'm told that the segment EF here is equal to FG, which is also equal to GH. Now the theorem we're going to use states that if three parallel lines, in this case we have 4, are cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So we're going to use that information. In number 1, I'm told that AB has a value of 5. And if that's the case, I want to know what the value of AD is. Well, again, if we have congruent segments, then this would also be 5, and this is also 5. So if I'm looking at the segment AD, that length, if you count that up, has a measurement of 15. Let's look at number 2. If AC is equal to 12, so this distance right here, if that whole thing is equal to 12, again, I know that each segment on that transversal cuts off congruent sides, so I know each segment is going to have a measurement of 6. So then I can say that CD has a measurement of 6. In looking at our next diagram, we're told that the segment BD joins the midpoint of two sides of a triangle. So this is a midpoint here, and this is a midpoint here, so I know this is congruent, and I know AD and DF is congruent. I also know a couple things. I know that BD is parallel to CF, and I also know by the theorem that BD is half of CF. So let's solve. The easier one to solve is going to be for Y. I've already labeled that these segments are equal. So I can say that 4y plus 2 is equal to 7 times the quantity of y minus 1. So I'll distribute and isolate my variables. So I have 4y plus 2 is equal to 7y minus 7. Bring my 4y to the other side. And I have 2 is equal to 3y minus 7. Add 7 to both sides, and I have 9 is equal to 3y. So y has a value of 3. Now I'm looking at x. I have BD is equal to 3x plus 5, and I have C is equal to 12x minus 8. Now I know that BD is half of 12x minus 8, which is CF. So I can do it either way. I can either double BD, or I can divide CF in half. So I usually think it's easier just to multiply something by 2 versus dividing in half, but in the end, algebraically, it's the same. So 2 times the quantity of 3x plus 5 is going to equal 12x minus 8. And then again I distribute, so I have 6x plus 10 is equal to 12x minus 8. Bring my 6x to the other side. And I have 10 is equal to 6x minus 8. Add the 8 and I have 6x is equal to 18. So x is equal to 3.